So we're talking about, industrial efficiencies. Bernhard, tell us about ABB and what your role is there.
Yeah, at ABB we are basically electrifying, automating and digitalization industrial production. And there are two basic categories of what you could produce. One is discrete products, cars, mobile phones, things like that, things you can pick. That's what we do in our robotics business, for example, where the robots pick individual things. And then there's these other industries that are much more hidden, that deal with stuff like liquids, water, electricity, gases that you can't pick. And they are typically operating 7 by 24 hours. And that's the typical processes that we automate. And if you think about the water that you get out of the tap, you always want to have that out of the tap. But there's actually surprisingly few people in the background needed to actually make that happen. And that's what automation is doing.
Great. And Amy, same to you. You're the general manager of AI at Shell. Tell us how Shell is using AI and technology to change your business or the industry at large.
Well, I think efficiency is a big part of it. So it's about how you try to get those, even a couple of percentage points improvement in efficiency can actually make a big difference to how much something costs, the benefits you get from it, and in particular in our industry with the energy transition, CO2 impact. And that can be absolutely huge. It can be a big part of our contribution to the energy transition. But it also changes what we can do. There are lots of things we couldn't do without artificial intelligence and other forms of automation, which mean that we can actually create new business models and do things fundamentally differently and really change our processes as well.
Great. And so now we've got some background and context to what you both do. Let's talk about industrial efficiency. For Bernhard, what has been the biggest benefit of AI and technology and on industrial efficiency? And just for the audience, are you able to give a few kind of examples of that, customer examples maybe?
Yeah, if you think about the history of the industry, is that you started out with installations that were not very complex. So people were actually able to control by actually turning a knob or whatever, watching certain gauges. Today we've got plants that have tens of thousands of input points of things to watch. And that's obviously no longer possible by just having a human do all of that. So all of that is taken care of by automation typically already. And it's maybe if I give you an example that you're familiar with, if you look at driving a car, if you actually engage the cruise control, you don't actually have to worry about how the petrol gets from the tank to the ignition chamber and how it's actually then converted into movement of your wheel. That's all automated. But what you still need to do is you decide you actually want to go to visit your aunt and therefore you have to go there. And since you're late, you have to go a bit faster. And that's all decisions that you take as a human. And it's very similar in industrial plants. There's a lot of things that is already automated, but then there's a lot of automation that is done. For example, to increase energy efficiency, to actually increase throughput. And it's actually becoming more and more complicated if you think about industrial plants being also more and more trying to use renewable energies. Yeah, because they are not always there. So if you've got electricity that's always there, automation is simple. But if you suddenly have to deal with the fact that you might have varying supply of energy, and then you have to control, well, which part of the production do I want to run now? What do I want to do later? That's all challenges that you need to take care of in the automation system in order to optimize what you're doing.
That's great. And Amy, the same to you. What do you think, has been the biggest benefit of AI and technology on industrial efficiency, especially in the context of Shell?
Well, I'd say similar things, but yeah, absolutely. You've got a huge footprint, obviously, of industrial installations, and these are dangerous for people. These producing sort of millions of dollars of product per day. They're extremely complex and increasingly complex. So it's that kind of efficiency gains and this kind of decision support as Bernhard is saying. So a big impact you have is just trying to make sure that things are more consistent, but they're also higher quality. And those are the two things you can get from, it's not just AI, it's also better monitoring. So if you think of the kind of Internet of Things technologies, by putting more sensors on everything, by just being able to track everything better and having more data, even without any kind of intelligence implied over that, just having an operator with much, much more information about what's going on means that you can run things a lot better. When you add into that, you automate everything you can, because actually you don't need to make these micro decisions about how the fuel gets through. But you can start automating that and then leave the operator with the really important decisions that have to be made. And also when you start automating more complex decisions, you can also leave them there to give a judgment call. You can get more and more recommendations and leave them there, we call it the human in the loop, to say, this is what we think would be the best way to optimize this. Now you decide. And so actually you're changing things from being something which is a mechanical process which just runs unless you start it or stop it, to something which can really be fine-tuned. And that can make a huge difference to how much you produce, how efficient you do it, your CO2 impact, and how safe it is as well, and the impact a human can have. So I often see it as augmented intelligence for humans, because the humans are still very much there at the centre, and they're aware of things like trading conditions, prices, what people are demanding, whilst making sure that this is running as well as it can.
Bernhard, you wanted to add to this?
Yeah, if I just can hang into that, typically in these highly automated installations, humans are needed to deal with abnormal situations. Yeah, if something happens that is something that is not expected. Now, if I try to describe how that has been handled without the use of these new technologies, is the operators who are sitting in front of screens are then getting these huge alarm lists that tell them, okay, something has gone wrong. And you typically have people today, baby boomers like myself, who've been in there for 20 years. They know exactly what to do. But if you think about the future, that's not the work environment that Generation Z people would be working in. Yeah, they don't want to scan through massive alarm lists. They actually want to use a system like the mobile phone without actually having to take a lot of courses and training and things like that. So if I just describe how we use new technologies and how we can use new technologies to change that, is if an abnormal situation happens, far before an alarm is generated, actually through data analysis, we can find out that something is going wrong. And if we find out that something is going wrong, we can actually also look back at data in the past, because computers are pretty good in looking at data. Has that happened before? If it happened before, maybe there was a reaction that actually brought the system back to a proper state, or there were multiple things that were done to bring back the system to a proper state. So you can actually propose that, okay, you could do this, this, or this. This has succeeded in the past. This had variable success. Do you actually want to simulate number one before actually applying it? And then you see, okay, what would happen in the plant if you apply this fix in the first thing. And then the operator says, yeah, it looks good, go ahead. So all of that would be done far before in the traditional system. The operator would see this alarm list, and there would be a lot of support from analyzing data, machine learning, artificial intelligence, to help the person to deal with the situation properly, and that way avoid that there's a standstill, there's a production loss, or whatever.
That's great. And, you know, kind of moving on from that, let's kind of dig into employee efficiency, like, you know, within a business. And Amy, you know, where have you seen the greatest impact on, you know, we were talking about Gen Z coming into the business, you know, new employees, people kind of understanding information probably in a different way now than they used to. So where have you seen the greatest impact on employee efficiency, you know, at Shell or within your industry? And, you know, if you could give us some examples, that would be great.
Lots of examples. So I think actually Bernhard's one was a nice one, and we've done exactly the same thing. So if you're looking at an engineer who has to fix something, do you just go with, I've got my 20 years of experience, I'll try my normal things? Or do you have sort of a recommendation piece which says, these are the top 3 things that fixed it before, because these are the top 3 likely things that are wrong? And that means that even if you're 20 years experience, that can be an incredibly helpful thing to have. If you're 2 years experience, it's even more important. So you're basically bringing everyone up to that level. You're still a very capable mechanic, but you're actually able to draw on decades of experience in a way that before we just haven't been able to without putting those years in. So that's one major way. Another one is just speeding up all the tasks we do. I mean, a bit like the advert we had at the beginning. There are lots of tasks we don't fundamentally enjoy doing, but we have to do them. Someone has to do them. So if I think about one nice use case we have is with our empirical sciences. We've got very big research labs in Shell. We've been operating for 100 years. We're working on a lot of stuff for energy transition. For example, development of biofuels, methane reactors and so forth, better catalysts. And when you go off and do some more empirical research, you're searching through reams of literature about this, journal articles, patents, all the rest of it, to try and find new ideas, what you should be testing, new dopants, new molecules, whatever it is. You're then trying to do a load of experiments. And if your data is poorly organised, you're relying on what you know and what your immediate colleagues know and what you talk about in order to try the next new thing. If you can use natural language processing to search these patent databases and these journal articles and all these old Shell reports about what we did 20 years ago, if you can use predictive methods to say, well, actually, we've done these 200 experiments in this area in the past, therefore, actually, we think that this is probably the best formulation. This is what we think you'll get out of it, given what you're looking for. That will massively speed up experimentation. You still need to do the experiments, but rather than taking 6 months, you might be able to do it in 2. And we've been using that very successfully across a range of different areas to try and just support people in their roles. So they get to do the interesting stuff and the thinking stuff, and some of the just getting a bit of decision support. In other ways, it's less about efficiency, but also safety. We have this massive footprint of assets. They're often very inaccessible or unpleasant places to work. If we can do things like, a big one is corrosion, huge problem in all these assets, particularly in offshore locations. If rather than having a person going around every day with a clipboard or 3 times a day with a clipboard, often to, particularly under coronavirus, this was a really hard thing to manage. If you can use fixed cameras or drones to do this kind of visual support, someone anywhere in the world can do the analysis of the visual stream, in addition to having machine vision support to identify where there might be something going on. And then that's a lot safer for the person because you only have to send someone out when there's a question mark or when something has to be fixed. But also you get a much more thorough coverage. We kind of worked out that actually just having fixed cameras in one particular location, you could get, in an hour, you could get equivalent of like sort of 16 hours of someone doing a round by exception. So that's a huge efficiency and it's a huge gain in safety. Another point about safety is just, I said about avoiding that, but we also have a partnership with a company called The Tech. It's a startup using actually similar kind of machine vision technology to actually intervene when we see something going on that's unsafe. It identifies when you're, say, not wearing a helmet in a dangerous area, or there are too many people, or you're doing something like there's a trip hazard, or just something else is going on, and you can intervene in real time. And these are all things that prevent the kind of accidents which make the working place unsafe and make it a much easier place to work and let you focus on the jobs you can do. So we're not getting rid of humans in any way, you're just hugely supporting the environment in which they work. That was a lot of examples, sorry.
No, that's great. Thank you. I'm sure the audience, learned a lot from that. And then, one thing about all of this, it's great, the automation, the AI, but there is a kind of, the other side to it where, it makes one feel that like the workplace becomes a bit less secure. And I wanted to kind of, touch upon cybersecurity, Bernhard. What do you see, there's lots of challenges around it. Like how do you kind of overcome that? Like what do you see are the challenges and how can we overcome that?
Mm-hmm. Yeah, that's actually a big concern among a lot of players in the industry. I remember we had once a discussion with a company that were very interested in using speech recognition in order to interact with the operators in an industrial plant. And we did this demo to them and everything great. And when we tried to install it locally, the company said, well, actually, no, you can't go to the cloud. You actually have to do that locally. And that, of course, reduces the quality of the speech recognition significantly. And so I guess to some extent, if we want to make use of all of these technologies, we also, number one, have to make the basic systems that we are using much more cyber secure. But we also have to create the trust in them being cyber secure enough. And if you look back, many of the industrial plants have been in operation for 10, 20, 30 years. Now, 30 years ago, nobody talked about cybersecurity. And that is, of course, resulting in all of the installations there not being particularly secure. The only way to protect it is actually to keep it away from the internet. Yeah, and so the clear direction is that the systems that we put into the automation of such a plant in the future have to be what is called today zero trust. Yeah, so in the past, basically, everything that was connected was trusted because, okay, you just connected it and there was no problem. But if you actually have to go the other way around, you have to build the system in such a way that you trust nobody. And only if you authenticate yourself and if you've got the proper keys and all of that works properly, then you're admitted to communicate and to do certain things.
Yes.
And so the whole system has to be built in a different way. And obviously, you also have to take care of that during the lifetime of the system. As these plants live for a long time and the threat profile changes year over year over year, you also have to be able to adapt and update all of these schemes continuously. And that's, of course, one of the major challenges that we have, because on the one hand, you want to have a system that is as modern as possible. But on the other hand, you also want it to still be operating the same things that you always did very securely, very robustly, never intervene, it should be running 7/24 and never be changed. So that's a bit the difficulty that we will have to deal with, but there are good ways to deal with that.
Yeah. And so the other kind of thing that I wanted to touch upon, and I know we're fast approaching the end, so I'll get them in. We're in the second week of COP27 in Egypt, and ESG and sustainability is central to like any business decision right now. And what do you see as the opportunities and the challenges around sustainability and automation, Bernhard, with those? I know you spoke about energy efficiency, and Amy, you touched upon the energy transition. So it would be great to hear your kind of, your opinions on this, or your experiences.
Well, if I look at what our customers are doing, there are a lot of developments in order to make the production more circular. If I take, for example, the example of a company in Sweden, RenewCell, they are actually taking clothes that people don't need anymore, and they are recreating actually the material that can be used to create new clothes. Yeah, and obviously it would be better for the clothes to be worn longer, but even if they are, this circular process is something that takes away all the waste. Or it's a similar thing, a plant in the US, or in Canada, it was an old refinery. It's actually repurposed now to take all of the oils from fast food chains that are used up and create fuels that can be used again. So all of these things are typically complex chemical processes that need automation. They also need energy. And then, of course, the energy efficiency of this whole thing, making the best use of potentially renewable energy sources in order to run this process are very fundamental. Or if you think about carbon capture and storage, it's actually also a very complex process. You have to deal with chemicals and everything. It's also a process that needs a lot of automation in order to make that happen.
Great. And Amy, Shell is kind of entrenched in sustainability and the energy transition. And how have you approached that? What do you see as the challenges? You're in the fossil fuel sector, so I imagine there's a lot of pressure to be as sustainable and as efficient as possible.
Yeah, and we've adopted some very ambitious goals. I think there are 4 ways in which digitisation supports four main ways energy transition. I mean, fundamentally, energy transition is about physical and chemical technologies, not digital ones, plus wide-scale adoption. And we can't get around that. But four ways digital can support. One is just in efficiency. You know, digitalization, artificial intelligence, incredibly good at working out, if you tweak this particular setting, we can do this more efficiently. If you change this process, we can do it more efficiently. And that can have a huge impact. An example would be liquefied natural gas. We worked out by just changing some of the parameters of the way we do things, you can, increasing efficiency by a couple of percentage points, you can actually basically save the equivalent CO2 emissions, equivalent to taking about 28,000 cars off US roads for a year. That's very, very substantial for what looks like a relatively small change. The second thing is in supply and demand matching. That obviously one of the big, as Bernhard referred to, one of the big challenges about more renewable sources of energy is their intermittency. And so we have to move from a purely kind of demand-led system, we just burn it when we want to, so we have heat or light or whatever, to something which is much more balanced. And so forecasting and matching is really important. And artificial intelligence is brilliant at that. A third one is, as I mentioned before, about supporting things like the research and development process. We can get to better fuels quicker when we actually support people to do their roles. And the fourth one is in monitoring. Things like satellite monitoring for ecosystems, all sorts of Internet of Things, and monitoring for how much CO2 is actually being emitted, where's it emitted from, therefore we can fix the problem quicker. These are all ways that this is actually hugely helping to support this transition.
That's really great. And moving on to, from the transition, we've got, a few minutes left. I'm really interested in, and I hope the audience is as well, in knowing about, what you guys see as the AI and technology trends that we should be watching for in the next 5 to 10 years. And, that can be generally all within a business and industrial context as well. So, Amy.
I think increasing powers of computation will be incredibly impactful, because at the moment it's still, when you've got huge data sets, it's still really expensive and really difficult. So quantum computing, all sorts of other things. Another one is just quite pragmatically getting your data together in a much better way. We're still dealing with huge legacy systems in most industrials, but as more and more processes come on board and things are digital right from the start, it'll just open up everything to the basics of digitization and AI, and we can get there a lot quicker. So those are the two main things I think I see.
And Bernhard, same question to you. What do you see as the biggest trends in industry, in the workplace, in the next 5 to 10 years when it comes to AI?
Mm. Yeah, and actually, just following up on what Amy said, if I think about it, we probably have something like 100 million sensors that go into our control system. So huge amounts of data that is typically not used for more than, just the basic controls. If you actually bring all of that data together, and that's really big data, with the data that you have from the typical IT systems. So this, what is called the operational technology, information technology integration, and with engineering systems, and making sure that actually you use this data in a proper way to not only do the operational things, but you control production, you actually also get into this issue of how do you deal with the supply chain, more in a part that is in the front end, how you get this stuff, but also in the back end where your customers need something. All of this integration of all of the data that we partly already have available, but that needs to be contextualized in a way that you can use it properly for decision taking. And for knowing that this piece of data means that in that context and can help you in that particular way, that's, I guess, something that is a hugely untapped potential still, and where I see a lot of potential in the future.
Thank you both very much. And I'd really like to thank you for joining us today as well. It's been a great conversation. Thank you. Mm-hmm.